Hey guys, so today we're going to do section 10.5. We're going to be talking about the laws of sines. And basically what the laws of sines are going to do is it's going to allow us to solve for every side and every angle of a triangle. Okay, so this is going to give us every side and every angle in a triangle. Okay, so the laws of sines is really helpful in a lot of different methods, a lot of different reasons why we need to be able to use the law of sines. The first thing that I want to do with you is just review really quickly finding the area of triangles, okay? So this is kind of review. So a lot of you know the area of the triangle formula as 1/2 base times height, right? But what if you don't know the height, okay? Obviously, you can go get the height, and that will, as a matter of fact, help you derive the following formulas, and I'm actually going to show you. If you want to do that, that's totally fine. But what if you don't know the height, okay? So the first thing I want to do is just draw a generic triangle for you. I want to remind you of a couple of details. First of all, angles we use capital letters for, right? Angles A, B, and C. And then side lengths we usually use lowercase letters, okay? So lengths, again, are normally lowercase letters. That's why the B and H are lowercase. Again, angles are capital. So, and then typically across from angle A, we put side A. Okay, across from angle B is side B. Across from angle C is side C. So if you really wanted to go through and do the trig for it, you could, but there is a formula for the area of any given triangle, and what you can do is you can take 1/2, you can do A times B times the sine of the angle that is in between it. So I don't know if you remember in geometry, you guys did all of this side angle side, angle stuff, right? So side angle side is when you have, the two side lengths. So here's my S and my S. And then the A, since it's between the two sides, is the angle in between it, right? And so notice this formula is doing A times B times the sine of C, which is in between the A and B. So this formula, this area of any triangle, can be used when you have sine, angle, side. So what happens if you have A and C, right? So if you have A times C, this formula will also let you find out the area of the triangle by doing the sine of the angle in between. So AC, sine of angle B. You can also do B and C, so sides B and C, and then times the sine of A. So one of my questions for you, one of my challenges for you is, where did this come from, right? So where in the holy world did this formula come from? And again, I've kind of already mentioned it a little bit. See what you think or what you can come up with. I want to go ahead and do a quick area problem with you so we can find the area of this triangle. I just want to go ahead and do that really super quick. But basically we have two sides, and then I have the angle in between. So I'm just going to follow this same formula and go figure it out. So the area of triangle ABC is going to be 1/2. I'm going to do 2.96 times 2.13 times the sine of 73 degrees. Now, keep it in mind, excuse me, if you're on a unit circle, right, 73 degrees, the sine of 73 degrees is going to be a value, okay? When I go to punch this into my calculator, the first thing I want to make sure is that I'm actually in degree mode. Thank goodness that I am. So I'm going to do 1/2 times 2.96 times 2.13 times the sine of 73, following this formula. And the area is 3.015-ish, okay? And so that's all we have to do, right? That's pretty much it. The really cool thing is that the laws of sines can be derived from this formula. So I don't know if you remember anything from geometry or not, but if you remember the laws of sines, so if you remember from geometry, the laws of sines look like this. So I did rewrite my triangle. I did redraw the triangle. I put it in a different order as I did on the other side. I can actually see it through my paper. I had angle A, it looks like, up at the top. As long as you know that angle A and side A are opposites of each other, it doesn't matter what form or what direction you draw your triangle in, okay? I do want to mention, though, that the one thing that laws of sines does not work for is when you are given side, angle, side. That's going to be a law of cosines, and that's going to be tomorrow's lesson, okay? So again, laws of sines is going to work for everything except for side, angle, side. Okay, so let's do a couple. So what if you are given, and let's actually talk about some of the other relationships between the sides and the angles that you guys did in geometry. So what if you are given an angle, and a side? Okay, and you're told to find all of the rest of the lengths and degrees of all of the different pieces of the triangle puzzle, okay? So let me show you basically what I'm talking about and what I kind of mean, okay? So here is a triangle, okay? I know it looks like an isosceles one, but it's probably not, okay? Definitely not drawn to scale. This is 40 degrees. Let's call this angle S. We're going to label this 49 and call this angle R. And so let's see, this is triangle RST, okay? I want to know what this side is, I want to know what this side is, and I know that this side is a length of 20, okay? So again, I'm given an angle, and a side. So I'm given an angle, and then this side right here, okay? So we're going to go do laws of sines, and we're going to go solve and get everything else. Okay, the first thing that I want to do is I want to go find what that missing angle is, and I don't need laws of sines for that. I can just use my brain for that, okay? So angle T, I know, is going to be 180 degrees minus angle R and angle S. So whatever 40 and 49 are, so if I get rid of those, okay, I know that angle T is going to end up being 91 degrees. Okay, again, totally not drawn to scale because this should be more than 90 degrees. Okay, what I want to do though is I want to figure out what is side T, what is side R. So I'm going to go do my laws of sines to get there. I know angle S and I know side S, so I'm definitely going to do the sine of 40 over 20. And I'm going to set that equal to, I'm going to start with letter T. I'm going to set that equal to the sine of 91 divided by lowercase t, okay? In a minute, I'm going to do a little bit of algebra and to figure out what that is. I'm going to go get the other side set up. So I'm going to do the sine of 40 degrees. By the way, this is really important that you're keeping track of what's an angle and what is a side measure. So don't forget those degree symbols. So sine of 40 over 20 is also going to equal side R, right? So the sine of 49 degrees over side R. And then I'm just going to do a little bit of algebra and see what they come out to be. Okay, so I did a little bit of algebra. I went ahead and typed some things in. Again, this is really important that you're using degree symbols to separate degrees from possible side lengths, okay? I did just want to show you really quickly. I did type these into the calculator. I typed them both in two different ways. This first one, if I scroll up, you can see how I typed it in. Let me hit enter so you can see it again. Just be careful, watch your, parentheses. So I want to do 20 times the sine of 91, close that parenthesis, okay? And then divide by the sine of 40. You can always do the alpha y equals if you wanted to get it into the fraction mode that I know some of you like so well. Okay, so those are just a couple of options. But here we go. We just found those two other sides of that triangle. Let's go do another one. Okay, so let's go do another one. So here we go. We've got a triangle, but this time we have angle, side, angle. So I've got an angle marked. I've got a side in between, and then another angle marked as I kind of go around my triangle. So again, if I just do the laws of sine, I can figure out what those missing pieces are. The first thing I'm going to have to do is to go find this angle, and so doing 180 minus the other two, okay, you should end up getting 16 degrees, so we can find that angle pretty quickly. And then I'm going to use the sine of 16 over 9. So the sine of 16 over 9 is going to equal the sine of 23 over f. I can do some algebra and figure it out. I can also do the sine of 16 over 9 equals the sine of 141 over e. Do a little bit of algebra and figure it out. So the laws of sines work out pretty well when you're given a couple of these things. Remember, side angle side is going to be a laws of cosines. That's another day. All right, so it is at this point when it gets a little bit hairy. So if you're given a side, another side, and then the angle, so you know a side, you know another side, and you know an angle. Okay, so I like to draw them this way better. So if you know this angle, you know what this side is, and you know what this side. Basically spelling this out backwards, right? This is when things can get a little bit on the tricky side. And this is where we're going to spend the next little bit of our time going over, okay? This would be the time when you would stop watching this video and go watch the other video, because we're going to talk about this in great, great detail.